Episode 49, The Syzygy Planet Hunter's Guide. And welcome back for another edition of the Syzygy podcast. This week, we're going to be talking about planets. My name's Chris Stewart. Sitting opposite me at the table here is Emily Brunston. Hey, Emily.
Hello, hello.
So, planets, you were telling me before that you're trying to collect the whole set.
I am.
What do you mean by that? What are we talking about today?
So I'm going to be able to see each one of the planets in our solar system for yourself.
And so you're trying to collect the whole set in the sense of with your own eyes.
Exactly.
But I mean, that might be unaided or aided with the use of technology of some kind.
It will require some assistance at some point.
Yeah.
Yep.
So that's what we're going to be talking about today, is how you too, you, the listener, at home, can collect the whole set, or as many of them as humanly possible, of the planets in our solar system, or maybe even beyond. I don't know. I don't know if there's a possibility of anyone out there being able to actually go and see an exoplanet. But anyway, we'll leave that for later on. But before we get into all of that, there's something that we need to do. We need to say hello to our latest patron. We got a message the other day saying that we have a new patron from patreon.com by the name of Keith Mazzullo. Keith, welcome aboard. It's really good to have you. Now, Keith said in his note to us, "Hi, I'm a former PhD student in solar astrophysics." No, you're not a former PhD in solar astrophysics. You're a PhD in solar astrophysics. Listen, I got my PhD in theoretical physics, like almost 20 years ago. I still call myself a physicist, mainly in the hope that by calling myself doctor, I'll get an upgrade on an airline one day. It's never happened yet, but you never know your luck. Point is, you're in the team. Yep. Stay in the team.
Once a physicist or an astrophysicist, always an astrophysicist.
Too right. I mean, if you can go to a party and say, "So who are you?" "I'm a solar astrophysicist, actually," then that's guaranteed to at least be a starter for a decent conversation. Anyway, welcome on board, Keith. Fabulous to have you along. And if you too, listeners out there in listenerland, want to help to support the show, then head over to patreon.com/syzygypod and check out the different options that we have available there for financially supporting what we do here on the show. Speaking of the show, let's get on with it. Emily, we're talking about spotting planets.
Yes.
Now, some of these are easier than others.
Yes, they are.
How are we starting this?
So, what I wanted to do with this show, as I mentioned to you, and we sort of started humming and hawing and thought, how are we going to do a show around this? I thought, well, it's not very useful for me to just tell you what's in the sky right now, because you may well be listening to this podcast a year from now.
Yeah, exactly.
From
like now doesn't work.
Part of the planet. You may well be listening from the moon. I don't know.
So saying what's in the night sky in York is not particularly useful. You know, what's up in the sky above York right now in late October 2019 is useful for like 3 people who might be listening tomorrow. But for everyone else, it's, well, thanks for that. I may as well just skip over to the, latest edition of This American Life or something. Forget it.
Yep.
So what are we going to do instead?
So we're going to look at why different planets can be observed at different times and why their visibility changes. And therefore, when you've got this toolkit of understanding when you might want to see different objects in the sky, then it makes it much easier to be able to spot them.
So we're kind of empowering the listener, aren't we? We're helping you to help yourselves to go and find some planets wherever they are, whenever they are in the night sky, to be able to figure out how can I collect the whole team.
Yes.
So where do we start?
So let's start with the construction of our own solar system as
Sounds
a
good.
reminder.
Sounds good.
So I've got this lovely website. It's called The Planets Today. I use it just to have a quick overview. Basically, you're looking top down onto the solar system. Where are all the planets scattered throughout the solar system at this particular time?
Okay, and this updates, so this is at any particular time.
Yeah.
You can just go to. So what's the website?
Theplanetstoday.com.
Theplanetstoday.com. Cool. Okay.
Yep.
Head over there. While you're listening to this, bring it up on your computer or on your phone. Does it work on your phone?
Yes. Yep.
Excellent. Go and bring it up so that you can see what we're looking at here in Emily's office.
Yeah. So this is quite useful because you can see kind of the relative locations to all the other planets with respect to the Earth. And it's, in fact, this is one of the main deciding factors basically as to how bright this planet is. So when people say it's the optimum time to view X in the sky, what they mean is it's quite high in the sky, so it's not going to be below the horizon, and they mean it's going to be pretty bright.
Right. So when someone says, hey, it's a really good time to be viewing Jupiter, for example, that means that it's up in the sky. It's not down on the horizon where it's going to be, hard to see because of lights and trees and all of that sort of thing. It's nice and high, and ideally closer to us than at other times.
Well, brightness is a factor of two things.
Okay.
So we got, yes, distance matters. So, for example, we go around the sun every 365 days.
Yes.
But every time we catch up on, say, another planet, say every time we catch up on Mars, it's not exactly the same distance between us and Mars. There are differences because the orbits of those two planets are not perfect circles.
Right. So when we sort of catch up on our trip around the sun and kind of come back around and lap back around Mars, for example, it's not always going to be the same. That closest approach is not always going to be, and it's really closest. Sometimes it's a bit further away, depending on where we are at in our respective orbits.
Yeah.
Yeah.
So that's an effect, but by far and large, the biggest effect is really distance based on the positions of the planets in their own orbits.
Okay.
So that's what we're going to be mostly talking about today. So I think it's time that we kind of learned a little bit of astrology at this point.
Astrology. This is new territory for us on the show. All right. Well, let's open that door.
It's going to sound like astrology. It's actually not. I have a deep suspicion that the planets today might be made for the purposes of astrology. But
that's all right. We'll steal that.
We'll steal that. But we're going to use a lot of terms that are astrological terms, or at least coined also by astrologists.
Okay.
But they really are astronomical. They do have a scientific definite meaning.
Okay. That's not to say that we are advocating the use of these terminologies for predicting the future on an astrological basis. We're not doing that. We're just co-opting the terms and saying it's all astronomy up until you start reading more meaning into that. Yes. So let's just draw a line under that. Carry on.
Okay, so let's talk about positions of planets and with respect to Earth. We've got some nice terms that are useful to know. So if you've got a planet that's orbiting outside of the Earth's orbit, so further away from us.
So that would be Mars, Jupiter, Saturn, Uranus.
Yep.
Neptune.
Yep. So those planets are superior planets.
Mm-hmm.
They're not better
they're not
than
better,
us.
They're just further out.
Further away from the sun.
Superior.
And their orbits, yeah. So these ones have two different points in their orbit, which is worth noting. So you have opposition.
Mm-hmm.
Now, opposition means you can draw a straight line between the sun, the Earth, and planet.
That's a syzygy.
It is. There's going to be a lot of syzygies in this episode.
Okay, there's one. We should have a bell. Ping, syzygy. Right?
Yep.
So that's opposition. Yep. In opposition. Yep.
And then you have the opposite of that, which is conjunction. So that means the planet's on the opposite side of the sun to us. So you've got planet, sun, Earth.
Planet, sun, Earth. Okay. So hang on. Let's work our way back through that one, because opposition to me sounds like it's other side. That feels wrong to me. Feels like we've got those the wrong way around.
No, we definitely haven't.
We haven't?
No.
So why is it called opposition? Opposition sounds like it should be on the other side.
Okay,
well, we'll just go with it.
It's
okay, so opposition means that the planet's on the same side of the sun as us.
Yes.
Right, okay. And conjunction means...
It's behind the sun.
Behind the sun. Okay. All right. Maybe that's just me that feels wrong. But I'm going to go with you on that. I'm going to assume you're right.
It's quite useful to have planets in opposition because it means that they are quite close to us, right? The relative distance between Earth and
because they're on
planet,
the same side of the sun.
Exactly, is the smallest. So that makes it useful to observe them then because they're going to be bright. But also they're going to be totally illuminated by the sun as well.
Right, yes, of course, because planets are shiny not because they're glowing with their own light, because they're reflecting light back at us. And so if they're on the same side of the sun as us, then that means that the light is bouncing off them because they're further away from the sun than us. So the light's bouncing off them and coming back to us. Yeah. That makes sense. Okay, yes.
Okay, so those are the useful terms for the superior planets.
Okay.
Now we've got the inferior planets.
Yes, which are, I'm guessing, the ones whose orbits are inside the Earth's orbit. Yep. So that would be Mercury and Venus.
Yes.
Yes, good. Excellent.
So we've actually got 3 different points that I'm going to talk about for these planets. So the first one is you have inferior conjunction. So that's when the planet is between us and the sun.
Right, yeah.
So you've got sun, planet, Earth. Mm-hmm. That's also quite useful if you want to have a transit, which is what we're going to be talking about later in this episode. And then you have superior conjunction.
Which is where it's on the other side?
Yep. Right. So planet, sun, Earth.
And they're both conjunctions?
Yes.
So there's no opposition?
No.
Oh.
They're both conjunctions because they're both inside our own orbit, if you like.
No, that doesn't make any sense to me. Okay.
But
right.
we would be
I'm just gonna
in
go with it.
opposition to a planet if it's in inferior conjunction to us.
What? Say that again. We'd be in opposition.
So if you
to
lived
a
on
planet if
Venus and Venus came into inferior conjunction with Earth, then you would say that the Earth's in opposition.
Oh, because it's on the outside. Okay.
Yeah.
So planets which are closer to the sun than us are never in opposition to us.
No.
But we are in opposition to them.
Yes.
Could this get any more confusing? Okay, all right. So inferior planets have inferior conjunction, which is when it's on the same side of the sun as us, and superior conjunction when it's on the other side of the sun from us.
Yes.
But it's still within our orbit.
Yes.
Okay, right. Yep, I'm going to hang on to that in my head.
Okay, and there's one more.
One more, yeah.
Which is elongation.
Yeah.
So elongation is basically when the planet is... it's not quite at 90 degrees, but it's nearly at 90 degrees. It's basically the farthest it can get from the sun from our point of view.
Right, okay. So, pulling that one apart, if it's between us and the sun, it's basically saying, in the sky, it's sort of passing perhaps over the face of the sun. So it's close to the sun in our field of view, is what you're saying.
Yep.
If it was on the other side of the sun, then it's actually potentially behind the sun and right close to the sun in our field of view. But if you're talking about not necessarily in terms of actual absolute measured distance, but in terms of where it is in the sky, the furthest away is when it's right off to one side.
Yes.
On that sort of 90 degree out on its orbit, out to one side. Right. But under those circumstances, you wouldn't be seeing that planet sort of reflecting light face on in the same way that you do for a full moon, for example. You'd only be seeing a bit of it, wouldn't you?
You get half a phase, yeah.
Okay, all right. So inferior planets are complicated.
They are. They are. And just to add, some extra lovely words to that, we have greatest eastern elongation and greatest western elongation.
Okay, well, I mean, I guess I can get a bit of a grip on that. Greatest eastern and greatest western is when it's out at elongation in the east and the west. Yes, well done.
So you're able to decipher some of the astrological.
If I think
nonsense.
really hard, yes.
the orbital positions are real.
Good.
That's the important thing.
Okay. Yeah. Right. It's what you do with that counts.
Yeah. So now when you're observing inferior planets,
it's
a little bit different. We don't want to have them at either of these conjunctions in some sense, because if it's in the superior conjunction, well, it's behind the sun.
Right. You can't see it.
No.
Right.
But because
there's a really, really bright thing in the way. It's going to blind you if you look.
Exactly. Yeah. Well, it's just behind it.
Yeah.
Not useful. Inferior conjunction, similar in the sense that you might be very lucky and have a transit, and meaning that will actually pass across the surface of the disk of the sun. And again, we'll come back to that. But most of the time, it will just pass close to the sun in the sky. And so you're just going to get blinded by the sun.
So all the planets in the solar system are, to give or take, are all in the same plane. But actually, they're not entirely within the same plane. I mean, if they were all exactly in the same plane, then every time Mercury or Venus came rolling past, it would be a transit. It would go across the face of the sun because everything's in the same plane. But it's not quite like that. They're out by a bit, and that bit is enough for them to maybe just scoot over the top or underneath as they come past.
Yep.
And it's only sometimes that we might see a transit.
Yep.
Okay.
So it's not very useful to try and observe these planets when they're in inferior conjunction either.
That's hard.
Yeah.
Okay.
So what you want is either this greatest eastern elongation or greatest western elongation.
When it's right out to the sides.
Yeah.
Okay.
So that way what you do is you either wait for the sun to set and then you've got the planet left hanging in the sky, or you get up early in the morning, you see the planet come up before the sun, and then the sun rises and you can't see it anymore.
Sure. Okay. How easy is that? How easy is it to see? Let's just stick with Mercury and Venus to start with, right? One of those planets is much easier to see than the other, isn't it?
Yeah. Which one?
That would be Venus,
because...
also known as the morning or the evening star.
Yeah.
Because it's closer to us and it's bigger, it's brighter in the sky. How many of these
things?
Even
more importantly, I guess it's closer to us, which means that it moves further away from the sun.
Ah, yes. Okay. So it's further out from the sun, which means its orbit is wider, which means that you don't have to look as close to the sun to see it. And anytime you're looking towards the sun, in the vicinity of the sun, that's quite hard.
The sun's light washes out everything else in our night sky.
And so the fact that Mercury is very small and quite close to the sun makes that much harder. Whereas Venus, far enough away that it's really bright. It's usually the first thing you see when it gets dark, if the timing's right.
So let's start with how to observe Venus.
All right.
So yes, you're right. You want to be quite close to the sun. Either the sun's just set or the sun's just about to rise.
Yeah. I mean, can we be absolutely clear at this point? Please don't go and look at the sun.
No.
Let's get that one out of
Yeah.
the way. Rule 0 of planet hunting is don't look at the sun. That's a dumb thing to do.
Very silly thing
Yeah.
to do. Yeah. Okay, so
Even if you're Donald Trump.
it is, yes. So Venus is super bright. It's really, really bright because it's got a very reflective atmosphere and it's close. So it appears to be, it's one of the brightest objects in our sky apart from the sun, basically.
Very reflective atmosphere, as in it's sort of shrouded in clouds and stuff, and it just bounces all the light off.
It just bounces all the light off,
Right,
yeah.
right.
Yeah. So Venus, probably most people have seen Venus whether you knew it or not at the time because
Right.
it's a very, very bright object when it's up.
Yeah, I mean, as I said before, it's known as, in many cultures, I think, as the evening star or the morning star, because when it is, not directly in line with the sun or behind it, it's coming up, ahead of the sun as it rises, or it's going down just behind the sun as it's setting. But it's this bright thing that as the sky starts to get dark, before you can see any other stars, there's this bright thing in the skies. Oh, what's that? That would be Venus.
Mm-hmm. So most people will have seen Venus. And if you have seen Venus, I've got a couple more challenges you can try to see Venus. Because you don't just have to appreciate Venus and its beautiful super brightness in the evening or morning sky. You can see more.
Okay.
You can actually spot Venus during the daytime.
Really?
You can.
How?
If you know exactly where to look. So if you use you can either use a very, very small telescope or just use a very good sky chart. Apps on your phone, for example, can do this. You can actually find exactly where Venus can be in the sky. And if you know exactly where to look, then you can get your eyes to focus and you can actually spot Venus.
Wow, like in the day.
In the daytime.
Yeah. Again, please don't look at the sun.
No, it's
don't
not.
look close to the sun.
No.
But you can I've got an app. I've got several apps, I think, on my phone, which I don't check terribly often. But with one of these apps, you can sort of look up, okay, so where, at this point in time, what's where, even though it's middle of the day, blue sky, the sun is out, but it can still say Venus is there, right? Look over to this, in this particular direction, go up, and there, that should be Venus.
Yeah.
And so if you go and find it, you can actually see it.
You can.
With your eyes.
With your eyes, yeah. So I have
Not
seen
with
Venus in the daytime.
Really?
Yeah, with my own eyes.
Okay, challenge accepted. I'm going to go and find Venus
Yeah.
on the next available bright sunny
to be
day.
fair, it's
Yeah.
not easy. It's not something if you're just scanning through the sky, you'll see.
Yeah.
You do really have to know where to look, and that's to get your eyes to focus in the correct space.
So it's not like seeing the moon during the day, which I still find it's amazing how many people still get surprised by seeing the moon during the day with this whole, but you can't see the moon during the day. The moon's a night thing. No, it's there. It's right there. You can't see it that clearly, but if you know what you're looking at, you know where to look, you can see it.
Yeah.
Cool.
So that's the first one, challenge with Venus.
Excellent.
The
Good.
second challenge does involve us having a small telescope. So this one is to see the phase of Venus.
Phase, as in similarly with the phases of the moon, depending on where the moon is pointing, you're only seeing the reflected light, right? And so
Yep.
seeing a full moon is because we're between the moon and the sun, and so we're getting the full reflection of the face of the moon back towards us. Whereas if it's off to one side, we're only seeing half of it bouncing off in our direction. Same thing with Venus.
Exactly. So when Venus is at greater eastern or western elongation, you'll see just about a sort of quarter to a semi full Venus. If it's getting close to the sun, then it will get bigger and bigger and bigger as it goes behind the sun. And then as it comes back around and gets closer to us again, it will get smaller and smaller. So you won't see the full spectrum of phases like we do for the moon, but you'll definitely you can see the change in how big or
Right.
small the
Right.
bright
But even being able
surface
to
is.
make out, like if it's far away from the sun, if it's right out to one side, even being able to make out the fact that it's not, it's not a disk, it's a part of a disk would be cool. You're
Yeah.
seeing the phases. So our eyes don't have enough resolution to be able to pick that out just by looking at it. It just looks like a bright dot
Yeah.
in the sky. A pretty bright dot, but you can't see the shape of it. So what do you need in order to be able to see that?
So
Would
you need
binoculars do? Would...
If your eyesight's pretty good, you can do it with binoculars or anything from a 6-inch telescope.
Right.
I've seen it through a 16, for example, Astro Campus, and that was pretty impressive.
Okay. So
You could
seek
you
out
could
someone...
clearly see that sort of C shape of the bright surface.
Okay,
of
that's
Venus.
worth doing. And that requires you seeking out someone who's got a bit of kit, nothing too fancy,
Yeah.
but more than just some opera glasses.
Local astronomical societies
Yeah.
and outreach facilities will have something like this.
Cool. Okay, I haven't seen that. Okay, so that's two things for me to do,
Cool.
is to have a look at the phases of Venus and see Venus during the day.
Yeah. And it's a nice historical thing. That was kind of the nail in the coffin for the Earth being the center of the solar system.
Oh, yeah, okay. Because I guess the logical reasoning there is, look, there's this thing in the sky, quite bright, maybe a star, maybe not a star, but look, we can show you that it's got phases in the same way that the moon has phases. So how does that show that? Like
So it means that Venus is going around the sun instead of Venus going around the Earth, basically.
But the moon has phases and it's going around the Earth.
Yeah,
So
but
how
it's
does-
this. You can't get a full Venus or a new
Oh,
Venus.
I see.
like.
Right. It's not the fact that Venus has phases per se. It's
Half
that
Venus,
as you
yeah.
track Venus, you can show, but if it was going around the Earth, we'd see this, then this, then this, and then this, and this. If it was going around the sun, you'd see this, then this, then this. And that's what we see.
Yeah,
So,
exactly.
sorry, Venus is going around the sun, not around the Earth. Ah,
It's all
clever.
a matter of
Nice.
perspective.
Cool.
Yeah.
Okay, that's two things to tick off. Anything else with Venus?
Well, there is another way to observe Venus, which is during a transit.
Ah,
So this is when the planet passes in between us and the sun's disk directly. So you get the dark shadow falling onto the sun. And this is, of course, is exactly the same as how we discover exoplanets.
Mm-hmm.
Now, the good news is you can see Venus transits with the naked eye. Well, I say the naked eye. I mean, without magnification.
Don't look at the sun, kids.
Don't look at the sun.
Don't do that.
But
Emily.
you can, with solar glasses or special telescopes, don't use welding masks and things like that. They just don't block out enough light. Just
Be safe, kids,
yeah.
okay?
Solar
do
glasses
this
are
properly.
only cheap online.
But what you're saying is, under the right conditions, with the right safety equipment,
Yes,
hashtag be safe, you can see it unmagnified.
unmagnified, yeah.
Wow, really?
Yeah.
Huh.
Now, the only problem with that is
Yeah.
we're not going to have a transit of Venus until 2117.
Ooh, okay. I don't think I'm going to be around. I'd be very surprised if any of our listeners are going to be around. That's a shame.
Yeah, so we had our opportunities in 2004 and 2012.
Yeah, I do vaguely remember that.
Yeah. So 2004, I was in the wrong part of the world. 2012, I was in the perfect part of the world. I was very, very excited. I planned an enormous outreach program. We had hundreds of school children coming to visit.
This was in New Zealand?
This was in New Zealand, and it was the 6th of June, 2012. And do you know what happened?
If I were to look up the weather on the 6th of June.
It wasn't just cloudy.
Yeah.
We got several centimeters of snow.
Oh, God. That's just rubbing your nose in it.
It was so bad the university closed and we had to send all the children home, and it was very upsetting.
I mean, look, snow's nice and all. Like on any other day, that would have been, hey, it's snowing, isn't that great?
So
Really?
I missed that one, unfortunately.
That's brilliant. Well, yeah. Sorry to say, it's not going to happen for another, what did you say, close to 98 years?
So transits of Venus come in this wonderful pattern where you have two which are 8 years apart,
Mm-hmm.
and then you have a gap of 105 years and then 121 years.
So it's almost like these things are predictable.
Indeed.
Wow, that's amazing. Just sadly, when you do the calculations, you find out that there's a really long gap. Yeah. Oh, well, that's Venus.
That's Venus.
So we won't be seeing one of those.
No.
All right.
But you've got a couple of challenges there to try out.
Yep.
Okay, so let's move on. Let's go in again.
All right.
Do the other inferior planet. So that's Mercury. Now, Mercury sounds like it should be quite an easy planet to spot.
Sure.
It's pretty bright, really. And, it's not that far away from us. And it goes in its orbit quite quickly, only 88 days.
Mm-hmm.
So
it's coming around and going out to its what are they called? When it's far out?
Elongations.
I've forgotten it already. The elongations. Getting out to its elongations regularly.
Yep.
Every 88 days it's coming around. So it should be trivial, right? Really simple.
It's actually pretty tricky to spot.
Right.
Mercury.
Why is that? Is that because it's so small?
It's because it's so close to the sun.
So close. Yeah. And the sun is, as we have mentioned before, very bright.
It is. So Mercury never gets very, very far away from the sun in the sky, which means if you want to observe Mercury, the first thing you need to do is find somewhere where you've got nothing on the horizon.
Correct me if I'm wrong. You want to try to see it before the sun has actually breached the horizon, so that you don't have the really, really bright thing, but you do have the thing which is very, very close to the really, really bright thing over the horizon.
Yep. So you can do that just before sunrise.
Yep.
Alternatively, you can wait till sunset when Mercury's kind of behind the sun, wait for the sun to go down, and then you can spot Mercury.
When you say behind the sun, you mean as in following it down the sky.
Yeah.
So it's either leading it up over the horizon or following it down over the horizon. Either way, that's possible. Okay.
Yeah.
Can I just ask, in terms of, like, if I'm imagining the night sky, right, and the sun is sort of, kind of thumb size in the sky, right? How many sun widths, how many thumbs away does Mercury get in the sky? Because I know that Venus, you always look towards roughly the part of the sky where the sun is-ish, but it can actually be quite a long way away in the sky. How far away does Mercury get?
So it's only a few, but the complicating factor, if you like, in this is that the angles are not straight up and down. So we say, for example, all the time, sun rises in the east and it sets in the west.
Yeah, it's a bit more complicated than that.
It's a bit more complicated than that. And the sun doesn't rise straight up.
No.
It rises at an angle.
Yeah.
So the best time to see Mercury is actually when you get the sun literally going rising or setting straight up and down.
Which is when? When's that? Is that
That's
middle of
during
summer?
Equinox.
Equinox, which is, hang on.
Or closest
Remind
to
me,
equinox.
is that middle of summer?
No,
No.
it's the other ones.
It's right, yes. Those are, what are they called?
Solstices.
Solstices, right. It's not the solstice, it's the equinoxum.
So equinox, equal
Equinoxes.
nights.
Right, which is sort of middle of spring, middle of autumn.
Yeah.
Right, yeah, when the sun's going up and coming down, pretty much directly bang on the horizon.
Yes. Well, if you live on the equator, it definitely will be exactly that. But anywhere else, it will have some angle, but it will be kind of a minimal.
As close as you can get.
Yeah. So that's quite nice because otherwise, if you have a very, very harsh angle, like you're close to solstices, then you're going to get basically the two setting kind of in parallel at the same time. Which is
yeah, that doesn't really
irritating.
work.
Yeah. Yeah. So if you want to spot Mercury, look for times where it's going to be at greatest eastern elongation or greatest western elongation.
Which your app can help you with.
Which your app can help you with. Or at sunrise or sunset and close to equinoxes.
Right, okay. And you are looking quite close. So you're going to have to be quick.
Yeah.
Because it's not, as you say, it's only a few sort of sun widths away from the sun in the sky. So you're looking either just before the sun comes up or just after the sun's gone down. And then you've got to look because you've only got quite a short period of time before Mercury's then going to set itself.
Yeah,
or the
up
sun's
to maybe
come
a
up.
couple of hours.
Right,
well,
okay.
an hour
That
and
long.
a bit, depending on when, as soon as it gets dark enough to spot it, if you like.
Yeah, okay.
But yeah, you do want that clear horizon. So watching sunsets on the beach, for example, could be a nice thing.
Yeah, a nice romantic outing with your significant other to say, let's go and watch the sunset. And by the way, Mercury, and that'll score your points.
Yeah. Or from the top of a hill, or just somewhere where you don't have trees and houses and all that kind of stuff.
Ideally not a
horizon.
really bright city either.
Exactly, yeah. So at the moment for us in New York, it is spottable in the morning sky.
Okay.
So just before sunrise. And that's about up to the end of the year.
Okay.
So.
And with the naked eye?
Yes.
You can see this?
Definitely,
All right.
Yep.
All right.
It's actually quite bright intrinsically, but because we're only looking at it through a lot of atmosphere, because it's close to the horizon.
That's the problem, isn't it?
It makes it a little bit dimmer, but still quite a bright object.
Okay. And this is at the point presumably close enough to dawn or, in other cases, just after sunset, where there aren't a lot of other stars. So you wouldn't be confusing it for something else? Like, is it obviously, okay, there's a thing there, that's Mercury.
It's quite useful because you can often see Venus and you can draw a line between the sun and Venus. It'll be on that line.
Oh, okay. Of course, because they would be roughly in the same plane.
Yeah, so that's a good way to check.
Yeah, so if it's way off at some other angle, you're thinking that's probably not Mercury.
Yeah, exactly.
Yeah. Okay, cool.
Yeah. Now, an interesting thing about Mercury is it is about to do two fun things in the sky. So the first one is, of course, it's about to transit.
Ah, yes. Now, when you say about to, when?
So this is the 11th of November.
So coming up very soon.
Very soon.
Yep.
So this is a transit of Mercury. And they happen more frequently than transits of Venus.
Because it's orbiting once every 88 days. And so even though not all of them go across the face of the sun, it's going to come around more often.
Yeah,
Okay.
exactly. Yeah.
How often?
So it's sort of tens of years,
Okay.
depending on
Because
exactly
I do
the time.
vaguely remember one back in the 2000s. Am
Yeah.
I right about that?
Yes, yep. I don't have the exact dates of all the previous ones, but I did look up. The next one's not, I think, till 2037 for
Okay.
us. So
Okay. So this is a good one to see.
this will be definitely a good one to see.
So given that it's a good one to see and it's coming up very soon, how How would one see that?
Okay, so Mercury's tiny,
Yep.
which means that even if you are wearing all the appropriate safety equipment,
Which you would be, because
Which you
remember,
are,
you
yep.
don't look at the sun. That's a bad idea. Yep.
yeah, exactly. So doing that, it's incredibly hard to spot
It's
it.
a really tiny dot. So
It's
you're
a
going to
really
need some
tiny
help.
dot. You need some magnification.
Okay.
Yeah, there's lots of ways to do this. You don't have to go out and buy fancy telescopes to do it. You can project an image of the sun using some pretty simple pieces of kit, and you can. In that projection, you can basically enlarge the size of the sun.
Right. You're talking sort of pinhole camera style.
Exactly. Yeah. So there's lots of instructables, if you like, on the internet to build your own.
We'll dig up a good
things.
instructable and throw it into the show notes and give you a couple of ideas of how you might be able to go and do that.
Yeah. And it's safe to look at projections of the sun because you've diffused all the light. So that's a really nice thing to do. And it's good because a whole group of people can look at it at the same time.
Yeah. It is important. I can't emphasize this enough, because whenever there is something like an eclipse or a transit of a planet across the face of the sun, then there's always someone somewhere who just does something horrible to their eyes. So I can't emphasize enough. You're not looking at the sun. I remember a few years ago when there was an eclipse or a partial eclipse here in York, and I went out to a primary school and we made pinhole boxes, projection boxes, and a bunch of the kids and the teachers didn't quite get the notion, and so they've got the box on their head and they're looking through the pinhole at the sun going, it doesn't seem to be working. No, don't look at the sun. Please, God, don't look at the sun through the little hole. Let it project onto the back. Anyway, we'll put instructions in the show notes. We'll figure that out. The other way, of course, that you might be able to see the transit of Mercury on the 11th of November is by going and finding your local amateur or professional astronomy association, because people are going to be out wanting to look at this, because it's not going to come around for another, what did you say, like 20 years?
Yeah.
So people are going to be looking at this.
Yes, definitely.
So
yeah,
check
for
it out.
example, at Astro Campus here in York, we have an open day. So you can come look through our solar telescopes, which are totally safe. They're special designed, and there'll be people there to help out. You can, and even if you don't have anywhere that you can access telescopes and you want to look at the sun safely, you can buy really cheap pairs of solar glasses online, getting delivered via Amazon or whatever.
Yeah, you've got time,
But do be aware that you probably won't be able to see Mercury through those ones, but you can see large sunspots and things like that, which is quite cool.
Yeah. Well, look, it's coming up. It's coming up soon. So check it out, because you won't have a chance to do that again for another 20 years.
Yeah. Unless you're in Australia,
Ah,
you miss out.
right.
Sorry.
Yes. Sorry, Australians. Just Australia?
Australia and parts of Asia.
Right.
Most of the rest of the
everyone.
world is fine.
Sorry, everyone. Everyone else can see it except for you. All right, moving on.
Well, yes, but there's one more thing about Mercury that's just
Oh,
kind
sorry,
of a little
I'm jumping the gun. Yep.
So one little last thing that's interesting about Mercury is that it is about to go retrograde.
Well, that sounds impressive. What does that mean?
It means it's going to start moving backwards in the sky.
Oh, okay. Yeah, this is interesting. Tell us about that.
Okay, so what happens is that we have the stars and the sun, which go, as we know, from east to west throughout the sky
Across
over
the
the course
sky.
of time.
Yep.
Now, it's actually, of course, an illusion. It's just the rotation of the Earth.
Yeah, we figured that one out a long time ago. Yeah.
But what happens is that because of the way that orbits, different planets are orbiting at different speeds, basically, they catch up on each other, which means that for short periods of time, actually all the planets in our solar system will appear to move backwards in the sky.
And this was one of the things that actually helped us to nail that whole Earth isn't center of the universe thing, and that there are things going around the sun. That whole idea was, how do you explain, right, smart person, if everything's going around the Earth in these nice circular orbits, how do you explain the fact that Mercury, and in fact all the planets, as you say, goes across and then seems to just sort of turn back every once in a while and backwards in the sky and then forward again? That doesn't make any sense unless you come up with very, very crazy ideas about, no, but it's circles on circles on circles and all of these things that people came up with in the past. Or the rather simpler explanation, which is that it's all going around the sun, around Earth.
So what's happening here is Mercury has basically caught up on Earth, and it's now passing us. It's in the fast lane and we're in the slower lane. And so for a little while, it appears to go through this tiny loop in the sky and move backwards. Now, when I say loop and backwards, I mean, if you went out and looked at where Mercury is at the same time every night or every morning, then it would appear to be in a different spot each time you went and looked.
Right. If you were to track that over time.
Yeah, exactly.
It's
So
not that Mercury's sort of flying and doing loops across the sky. It's not that.
You can't watch it in real time.
That would be cool, but that's not what we're talking about.
Yeah. So normally it would move just, westwards through the sky as the rest of the objects do. But then at this point it goes retrograde.
Cool. And that's about to happen. When's that kicking off?
So that starts on the 22nd of November.
Right. And how long does that last?
So it'll be until Mercury basically moves around to the back. So hang on. Yeah, this would be good. Oh, no, because the Earth moves
Emily's
as well.
Emily's thinking really hard right now.
The geometry gets really hard.
Let's call it a couple of weeks. Look, you're forgiven for not having that one at your fingertips.
Yeah.
Cool. All right. Anything else about Mercury, or shall we move on?
So we move on.
Okay.
So the next one we have in the sky, which also quite a lot of people will have noticed at some point, whether you've meant it or not, is Mars.
Mars. Red.
Red planet.
Mars is red.
It is lovely and red, and it deserves its name, right?
Yeah, it does. But also, it's one of those ones where, you're looking up at the sky, and that's quite a bright one. I wonder, is that a star? Is it a planet? It's conspicuously red. Not in that same way that, is that kind of red or is it kind of blue? Mars is red. It's clearly red. It's one of those things that you see in the sky and you go, that's red. There's no doubt about it. And that's a good indicator that that's Mars that you're looking at?
If you're sure that you're looking in the right direction.
Sure, okay.
Yeah.
I mean, check it against your charts or your app or your website or whatever it is, or your local friendly astronomer. But it's fairly clearly
It is red. It's definitely red. There just are a couple of other things in the sky that are
Right.
also red.
Okay.
Like Betelgeuse, for example.
Sure.
It's not the only red thing, but it's usually the brightest red thing if you can see it. So Mars for us is slowly getting fainter. We had this opposition a couple of years ago, so it's we had a really good one basically where Mars was very clear. We saw some wonderful dust storms, for example, come across in 2017. So it's a little bit fainter at the moment, but it's still pretty visible. It's a nice thing to look at. For us here, it's moving through the morning sky at the moment until about the end of the year. So,
and is it visible from all parts of the Earth? I mean, I know that there are some things in the night sky which are better viewed from the southern hemisphere and from the northern hemisphere and so on. Where do planets sort of fit with that? Are planets generally viewable by most people in most places?
Yes, because planets move on the ecliptic, which is the path of the sun through the sky.
So if you can see the sun,
yes,
which pretty much everywhere other than the poles in the middle of winter, pretty much is everyone.
Yes,
yeah,
exactly.
Okay,
yeah.
Cool.
So it just depend on the time of year.
I hadn't really thought that one through, but that makes sense.
Yeah, exactly. Which ones are in the morning sky and which ones are in the evening sky.
Sure. Okay.
Yeah, so that's Mars, and it's a good one to spot. It's one of the easy ones. You can bag that one pretty easily.
So that should be an easy get.
Yeah.
Okay. All right, that's Mars.
Yeah. So next one,
Jupiter.
Jupiter's again quite an easy one to spot. It's very bright, even though it's super far away.
But it's really big.
Yeah. Mm-hmm. It's kind of a whitish silver color if you stare at it for a while. I get more silver out of Jupiter.
Okay.
It's a bit hard to see at the moment for us here. It's it's really summer at the moment. It's a better object to see in the evening, but you can get a glimpse of it if you look through, finding out when exactly is it going to be in the morning or evening sky.
Why do you say it's a better one to see in the evening?
Just because it's a bit more sociable timing.
Oh, I see. Right. It's got nothing to do with the planet. It's got to do with look, I can't be bothered 2 o'clock in the morning. Forget it. But oh, look, 9 o'clock at night. Yeah,
it gets a bit higher. I mean, when I first arrived here a few years ago, we had an observing project that our students did, which was looking at the moons of Jupiter through a telescope, which is a wonderful thing to do.
That was my first proper telescope experience that had me just jaw on the floor. I can see a disk, which is Jupiter, and I can see 5 dots lined out across it, and those are moons. 5?
4.
4? Okay, I was making that up. 4 dots.
There we go. Yeah.
Which were the moons, and it just blew me away. It's brilliant. Absolutely brilliant. How big a telescope do you need to actually be able to see that kind of detail?
Not a super big one. Anything from binoculars you can start to see the moons of Jupiter. Mm-hmm. So they move around, of course, in their own orbits as well. So depending on the time, you definitely do need to look up to figure out which one's which. It's really not obvious, but you can sort of see they're in a line going around Jupiter. Sometimes you see 1, 2, 3, or 4, depending on how close they are to the planet itself.
Yeah, that's really cool. I mean, it's such a good thing.
So that's useful. Another way to help out if you're looking for planets, of course, and Jupiter's a good one to try this out with, is that they shouldn't twinkle.
As in with the naked eye?
Yeah.
Yeah. Because stars twinkle, but planets don't twinkle.
Well, at least planets don't twinkle much.
Okay.
Yeah.
Why?
So stars are point sources of light. They are so far away that they really are just a tiny, tiny pinprick of light coming to us on Earth. And when that light hits the atmosphere, it gets wiggled around by all the thermal motions and so on in our atmosphere, which makes them appear to twinkle. Now, of course, light from the planets is coming through exactly the same atmosphere. The difference is that the planets are not point sources. We can see them as disks, especially through telescopes.
I find that amazing that makes a difference, because with the naked eye, I mean, you can't tell that Jupiter or Mars is a circle, is a disk, as opposed to a dot. Like it's a point as far as we're concerned. But in the physics of the light coming through the atmosphere, there is enough of a difference in that absolutely minute difference between a star, which is really, to all intents and purposes, small enough to be a point, really, really bright, but a point, and a planet, which is a disk. There's enough physics in that to say that one twinkles, that one doesn't.
Yeah.
I find that amazing.
It is. The way I like to think about it is kind of like if you had a CCD camera, your light from a star would only fall on one pixel.
A CCD camera, as opposed to the other kind these days. Basically, what you're saying is you've got a camera, a digital camera.
I'm a little bit old-fashioned, aren't I?
A camera.
Yeah.
Yeah.
So
unless you pull out your old film camera, which no one's doing these days. So, yeah, you have a camera.
So your light from your star would fall on one pixel, and that can wiggle around, so it falls on all sorts of different pixels, so it looks like it's twinkling.
Okay.
Whereas your light from, say, Jupiter might fall on 3 or 4 pixels. So if they wiggle around, then it kind of doesn't make as much twinkling.
That does make sense. And presumably the same is true on the back of our eye, that we don't see it with our actual unaided eye, because the pixels on the back of our eye, which are our rods and cones collecting the light, even though we don't see it as a disk, we see it as a dot, there's still enough there to be able to tell the difference between a twinkle and a not twinkle. That's amazing.
That's really cool, isn't it?
Very cool.
So that's Jupiter. Now, one thing I was messing around in one of my favorite programs called Stellarium. Mm-hmm. It's a free-to-use piece of software. I know we're plugging all sorts of things.
Oh, that's all right. We'll put a link in the show notes.
Yeah,
it's free.
It's worth it. Yeah,
we're not making any profit off sales from Stellarium, are we? We should.
No. It's free.
No, it's free.
It's good that it's free. At least it's free for computers. I think there's a small charge for the app. But it's really nice. You can just put in your location. It shows you your night sky. You can mess around with all sorts of things. And I was looking at, when can you observe all these different planets? And I just happened to come across this interesting cluster, which is going to happen for us. And the 18th of March, very close. 2020. In the sky, you're going to see pretty much in the same location Saturn, the Moon, Jupiter, and Mars.
When you say in the same location, like how close?
Quite close, in a little cluster that will be, just a few thumbnails across.
Oh, that's an astronomical photographer's dream.
It is.
That's awesome.
Yeah, and I just happened to be messing around and I saw that. You do have to get up about 5 a.m. at least here to see it.
Totes worth it. Yeah.
I think so. Yeah.
Yep. Just hope for no snow.
Just a fun thing that you can do is look for these kind of groupings and clusters.
Nice one. Okay. Anything else about Jupiter?
That's pretty much Jupiter. But
cool.
Your challenge for Jupiter is to if you want to get a small telescope or binoculars, try and spot the moons.
Yeah, I mean, go and find it per se. Go and see it, and then get some help, a little bit of magnification, and see the moons, because it's so worth it. Yeah, really is. Okay, on to the other one that's worth it. Well, I mean, they're all worth it, but another one which is really cool.
Yep, and also quite easy to do. Saturn, yes. So I don't know if this is just my romanticism, but I see Saturn as a whitish gold colour, opposed to Jupiter being whitish silver. But
I see. The hierarchy of colours in Emily's mind.
Maybe that's just me. Mm-hmm. So Saturn is an easy one. It's a really bright one.
Because it's really big. Again, not as big as Jupiter, but big.
Yep, and reflective. Mm-hmm. So that's nice to see. We can get it at the moment. It's nice during sunset here in York during November, so we can spot it. And one of the interesting things, of course, if you look at Saturn through a small telescope, is you can see the rings.
Yeah. I mean, you can't, with a small telescope, you can't pick out, the individual structure of the rings, but you can see it's a disk and it's got this thing around it. Yeah. Which, depending on the angle of Saturn in the sky to us, like I'm assuming that at times that ring is quite very much side on to us, and sometimes it's tilted a little bit.
Exactly. So this is the interesting thing about another kind of seasons, if you like, of Saturn. We go through phases where the rings are basically edge on to us. Well, not fully, but as close as they get. So you can see more of the detail of the rings. And then we go to a point where the rings are kind of perpendicular across the surface. So they just look like a line across the surface.
So it really
Saturn.
does get very, very far over, where you can can you actually at any point see from Earth, like the planet with the ring around it?
It doesn't quite go that far.
Not quite that far, but quite tilted up
It does
at an
tilt
angle.
out. Yeah. So the maximum tilt was back in 2017. And so we got some fabulous pictures of Saturn then. So we're coming back off that and heading towards being edge on again. And we get to pretty much fully edge on at about 2025.
Right. And you can see that with a modest telescope.
Yes.
Yeah.
Yeah.
Very
So
cool.
Very, very nice. So that's the challenge for Saturn. If you've already got bagged Saturn, try and look at it through some.
Saturn's got a lot of moons too. In fact, I heard a while ago that Saturn has actually overtaken Jupiter
It has?
on the moon front. It's got more moons, like lots of them if you start counting them up. There's lots of tiny little ones.
Yeah, nearly
you
100
see,
now.
Can you see any of Saturn's moons?
You can see Titan with a reasonable telescope.
Right.
So
It's not as easy as Jupiter,
It's
though.
definitely not as easy as Jupiter.
Right.
Yeah.
Is that because the moons are smaller or because the rings get in the way?
It's the distance that starts
Right,
to
of course,
kill
because
you as
Saturn
well.
is
Yeah.
considerably further away.
Yeah.
Yeah.
And so Titan's the easiest moon of Saturn to spot, and I think it's still pretty faint. So you gotta know where to look. It's a bit further away from Saturn than the moons of Jupiter.
Okay. But that's another relatively easy get is, first of all, find Saturn and then get some help and see its rings. It's worth doing.
Really, really cool.
Yeah. Okay. Moving even further out, we've got...
So this is the end of our tour that you can do with the naked eye, unfortunately. I've heard reports that you can see Uranus with the naked eye, but it's really not easy.
You've really got to know where you're looking and...
You've got to have a really dark sight.
Yeah.
Yeah. So I think unless you're really up for a really big challenge and you've got a really dark place.
I mean,
to
that'd
go.
be a great box to be able to convince yourself you can tick, is I have definitely worked that one out. But otherwise, you're going to need some help.
Yes.
Okay.
Yeah. So Uranus is best with a small telescope. It's actually a really good time to be viewing Uranus because it's actually opposition today.
Oh, there you are.
Coincidentally.
Oh,
Yeah.
as it turns out. Now, today, this being late October into November here in York in the Northern Hemisphere of 2019, you might be listening to this at home at any time, but if it happens to be fairly close to this, and, I mean, Earth is moving around in its orbit reasonably slowly as far as days and weeks are concerned,
Exactly.
and Uranus is moving even slower than that. So it's
Yeah.
going to be in opposition or close to opposition for
a few weeks.
A few weeks.
Yeah, exactly.
Okay, so you've got a bit of time.
And then come again this time-ish next year.
Sure.
Basically.
But
So-
in order to tick this particular box, you are going to have to go and find someone with a telescope who's
Yes.
prepared to point it in the right direction for
Exactly.
you.
Yeah. So we actually had to go with this last night when we were out observing, but it
Mm-hmm.
was just a little bit too low.
And do you need a decent telescope for it, or would a
small
modest...
telescope is absolutely fine.
Yeah.
Yeah. It's only just beyond what you can see with your eyes. Binoculars, you can actually spot it if you're
Right,
looking in
if
the
you've
right
really got a steady hand and know where you're pointing.
place. Yep. And then it should look sort of a little bit greenish if you get enough light from it.
Okay, cool. All right, tick
that's
that one
Uranus.
off.
Yep. Neptune, absolutely need a telescope.
Yeah,
for
this one's really hard.
Yeah.
Yeah, I mean, still quite a large planet. It's considerably bigger than the Earth,
Yeah.
but a very long way away.
Yeah, it's nearly as far away from Neptune as Neptune is away from Jupiter. So
Wow. So we're really
from
starting
Saturn,
to...
sorry, yeah, from Saturn.
We're really starting to scale up now.
They're the big distances. If
So-
you've ever walked or cycled any kind of driven a model of the solar system,
Which you can do here in York.
You can, and lots of places around the world have them. You'll notice that, you get to about Saturn and then it's just, ugh.
How far do we have to... Can we just turn around now? Isn't that enough? Have you ticked this particular box? Have you seen Neptune?
No, I don't think I have.
that
So
one
I think this
remains
is going
for
to be
you.
one of my challenges this winter to get out and spot Neptune.
Challenge on, listeners. If you can get to Neptune before Emily does, what would they have to do that?
So you need a small telescope
Mm-hmm.
and you need to get the coordinates of Neptune, and lots of computerized telescopes will have this built in, so you can just point and go.
I mean, that's the thing, isn't it? It's no longer sort of get your sextant out and line it up with whatever and point it up in this direction. You've got, like, these are computerized.
Yeah.
And they'll go, Neptune, yep, bang, there it is. Have a look.
Yes, but
You haven't done that.
no.
What do you do with your
I
time?
don't. I get distracted by other wonderful things to
Right.
observe in the sky.
Yeah,
I suspect.
fair enough.
But yeah, if you do see it, it should be a sort of a slight bluish tinge to it. So So that's nice.
Cool. Would you be able to, with a let's say a modest telescope, would you actually be able to see that it's more than just a dot? Like, are you going to be able to pick out that it's a disc?
You can't get a disc, no. It's
too far away.
Yeah, but if you get this larger size of amateur-sized telescopes, so say maybe around 16 or above inches, then you're going to definitely start to get some colour information. So you just need it to be bright to get the colour.
Okay, so that's your challenge, is to be able to see Neptune and see its colour.
Yeah.
Excellent.
Cool. So now I'm afraid we're getting to the ultra hards. But the good news is...
Well, I mean, we've done all the planets now.
The good news is the next one's not technically a planet.
Yeah, so you'd be like, this is a box that's in pencil rather than in ink.
Yes.
This is the bonus, extra, super hard, but totally worth it. Pluto.
Yeah.
How do you see Pluto? I mean, Pluto is really far away.
It's really far away.
And it's really small.
Yeah.
So small that some time ago, not so long ago, they said, you're not even a planet anymore. Sorry, Pluto. You're a, what is it now? It's
dwarf
a dwarf planet. Pluto, the dwarf planet, explanet, subplanet. Or is that a thing? God, careful.
No, yeah, you
Dwarf
can't
planet.
start inventing
No,
words now.
just let's not open that can of planetary worms. Pluto, what would you have to do to see Pluto?
So Pluto's 14th and a half magnitude.
Okay, remind us again what that means.
That means very faint.
It's really hard to see.
Really faint. I mean, this is kind of a similar brightness of planet that we were looking at, brightness of star that we were looking at with Kepler.
Right, and that's like a whole dedicated orbiting telescope. So, yeah, that's hard.
It's really faint. Now, it is possible, and even with a kind of on the larger end of amateur telescopes,
How
it's
did
possible.
they even see it in the first place? How? Because it was when was Pluto found? Roughly, give or take. Was
Why
it
do
like
you ask me these questions?
100 years ago? Not even?
I don't remember the date.
Anyway, how the hell did they even find it?
So Pluto's discovery was based on a very meticulous search of
No
photographic
kidding.
plates.
Yeah.
I mean,
This almost invisible dot moved slightly to the left because, I mean, its orbital period is stupidly long.
Yes.
So it's not moving far
No.
in every... Anyway, all right. So let's
Tiny,
assume that you
tiny.
did want to do the ludicrously close to impossible and actually try to spot Pluto.
Yeah, it's not easy, but it is possible. Okay, so as I say, the larger end of amateur telescopes, so I think our 16, we could just do it. Now, the harder part is if you don't have super accurate pointing, meaning that your telescope is so well tracking on the sky that you can just point it at something incredibly faint and it will be bang straight there, which is, it's rare to get pointing that's good. I mean, I can't...
This is hard.
Yeah, I can't overstate how difficult that actually is.
So if your telescope, if your calibration system off by just a very small amount, it'll be tracking the movement across the sky of nothing as opposed to a really, really faint thing.
Exactly.
Right.
So this is why most people, when they do it, use a method called star hopping.
Oh, okay.
So basically you find something bright that you know.
Right.
And at the moment, actually, Saturn is not too far from Pluto in the sky. So Saturn's a good one. And then you use some very good sky charts and you hop using your telescope to the next one that's in your field of view, to the next one that you know what it is.
This is totally the equivalent of when you're looking through binoculars and you go, oh, God, what am I looking at down there? Okay, well, see that tree, see the tall fir tree, and then slightly to the left of that, there's the church, and then just up from that, and then over there, see that? That's the bird that I'm talking about. It's the equivalent of that, is look for Saturn. Easy, we've got Saturn, and then just over from Saturn, there's a slightly blue star, and up from that, there's a little trio of stars, and then Pluto is just over from there.
Yeah.
Right, clever.
So that's the way you can do it. If you do have a very well-aligned, very accurate pointing telescope, you can push go to as well.
just look for it and find it and show it to me. But that requires good stuff. So,
It really does,
so that's going to be a very challenging one to tick, but not impossible.
No.
None of these are impossible. Cool, go and collect the whole set. Anything else on the bottom of this list for people to tick?
Well, it turns out there's more planets in our galaxy than just the 8 and a bit that we've mentioned.
We have noticed this, yes, in recent times. There
So-
are several thousand exoplanets that we have found. But surely, Emily, none of these are ones that we could spot with the naked eye or even a modestly priced amateur telescope.
No, you're quite right. Well, Sort of.
Okay.
Okay, so first of all, I'm not going to give you an exhaustive list of how to find the 4,000 or so planets that we've found.
That's a
in our
whole
solar
other
system.
episode. Yeah.
I mean, this is a long episode as we're going. We don't want to carry on for another 4,000. However, what you can do is, first of all, I've written down the 3 brightest stars that have exoplanets, and you can find them.
Well, that's cool. I mean, at least you can find the stars and say around that is a planet. I can't see it, but it has been found.
Yeah.
That's kind of fun. Yeah.
That's really fun. So the 3 brightest ones are 3. I've chosen, well, they happen to be spread between the northern and southern hemisphere. So everyone should be able to see one of these. One is Fomalhaut. And Fomalhaut has a planet called Dagon.
Mm-hmm. So this one actually has a name.
Yeah.
Oh. So not only is it a star that you can see that has a name, and you can find it and you can know that there's a planet around it, but that planet has a name as opposed to a bunch of letters and numbers.
Yeah, so Fomalhaut A has planet Dagon. It's in the constellation of Pisces Austrinus, which I had to look up.
I haven't heard of that one either.
It's actually part of the foot of Aquarius.
Oh, there you go.
It's kind of a fish that's on the foot of Aquarius.
A foot fish.
It's being, I don't know, maybe the
One of
water's
those,
being poured
one of
on
those
it.
fish that nibble the skin off your feet. You know, those ones?
Except it's a bit bigger than the foot itself, I think. But
It's a big fish.
yeah. So that's quite a cool one. It's also quite a nice planet because it's the first one that we ever took a picture of.
Ah, excellent. Well, that's a really good one to tick then. Tick that box.
Yeah.
Go and find that one.
And it's a cold Jupiter exoplanet. If you're interested, you can go read about Dagon.
So that's a Jupiter, like big planet, big gas giant that's a long way away from the particular star.
So if you can see Aquarius in the sky, then that's one to.
All right.
to
Well, we'll put a
spot.
link to that one in the show notes.
Nice
Go and
and
look it
bright.
up.
Yep.
Tick that box.
Next one's Pollux.
Pollux. I've heard of Pollux.
Pollux is quite famous star.
Is one of the pointers?
Not quite.
No? It's one of the part of the Southern Cross?
It is a twin. There's a Clue twin.
Oh, no, tell me.
It's one of the 2 stars of Gemini.
Oh, okay. Sorry. Yes.
Yep. So Pollux and Castor. So Pollux, one of the twins, definitely has a planet. That planet also has a name. It's called Thestius.
Mm-hmm.
And it's a hot Jupiter
Very
exoplanet.
nice. So this is Jupiter size, big gas giant, but close to the star.
Yeah.
Excellent.
Quite a nice
So it's a
one.
different checkbox. Worth seeing both of those.
Yeah. So the Pollux is one we can actually see in our York's sky at the moment. It's
The star, not the planet.
Yeah, the star. So it's in the evening. It rises just after Orion, basically, Gemini.
Cool. So that should be an easy one to find.
Yep. The last one, which is also super bright, is Alpha Centauri B.
Ah.
Well, Alpha Centauri, the system. I mean,
Sure.
you don't need.
You're
can't
not going to
spot
be able to
the
tell the
2.
difference between the 2 without a lot of help.
Exactly.
Yeah.
Yeah. They're very close together at the moment. So this is a triple star system, actually. You've got Alpha Centauri A, B, and then you've got Proxima Centauri, which is a lot fainter. You can't see it with the naked eye, but it's part of that triple system. And it's Proxima that has the confirmed exoplanet.
Right. So go and, I mean, this one's it could be more complicated, but we'll make it easy for you. Just go and find that system, and that'll do. You can tick that box.
Yeah, exactly.
Get that one for free.
And that one's a potentially habitable planet.
Ooh. So we've got cold Jupiter, hot Jupiter, and potentially habitable Goldilocks zone-esque planet. 3 different checkboxes. Do you know what I think we should do? I think we should draw up a checkbox list for listeners to be able to go and download and start checking them off.
Yeah, that would be fantastic.
We'll put that in the show notes along with all
may
of these
involve
links.
may involve some travel, which is not necessarily
Not a bad thing. See what you can do.
Yeah. So the Alpha Centauri system is really visible only from quite southern part of the southern hemisphere. So you're talking about Australia, New Zealand, Chile, South Africa.
Right. Argentina. So if you have to do a good trip down to the southern hemisphere, if you live in the north, it's worth it. Totally worth it to completely fill out that checklist.
Exactly.
Anything else?
So I was thinking about the way, so this is the confusing thing. So the stars in the sky move from east to west.
Yep.
They rotate through the sky because of Earth's rotation. The planets, and the reason that we spotted them as planets, because planet literally means wandering star.
Yep.
So we spotted them because they were moving differently to the rest of the stars. And the way that they were moving differently is that each night they would appear to be rising a little bit later, let's say. And lots of things do this. So the planets do this, and also the moon does it for a slightly different reason. So the planets will be up in the sky a little bit later. So in some ways, if you were to track where a planet was in the sky every night, it would be moving eastwards.
Right.
From
Yes,
night
that
to
makes
night.
sense. Yep.
So when it goes retrograde, it actually goes westwards for a little bit.
Gotcha.
And
Okay.
then goes eastwards again.
Okay.
Now, that's quite cool. Now, the moon does the same thing. Now, this is where it gets really tricky.
Mm-hmm.
So you have to bend your mind around the orbital mechanics here.
Mm-hmm.
The moon is super synchronous. So actually, it rises later every day because of its own retrograde motion. So super synchronous means that basically the moon is going around the Earth slower than the Earth's spinning.
Right.
The moon takes a month to go around the Earth.
Yep. And the Earth's
whereas
spinning
the Earth
every day.
spins 24 hours. Yeah. So every time we catch back up on the moon, it appears to be moving retrograde.
Sure. Yep.
But it rises later each day, 50 minutes or so.
Okay.
So it's actually quite cool. So the moon is in this retrograde motion all the time, but not for the reason that you might think because it's moving like the planets.
Yes. It's complicated, isn't it?
It's really
That's all
complicated.
you have to think about.
I've got an even better example.
Go on.
Okay, so Mars.
Mm-hmm.
Okay, so Mars has two moons, Phobos and Deimos. So Deimos is super synchronous and Phobos isn't.
Why?
So Deimos is going around slower than Mars takes to spin, whereas Phobos is going around faster.
Faster.
So
wow.
that means that they both are actually traveling eastwards in the sky,
Yeah.
like literally. But because Deimos is super synchronous, it appears to travel westwards and retrograde. So if you were to observe the two moons in the sky, they would appear to move in opposite directions.
That's doing my head in. That's doing my head in. Now, again, we're talking about if you were to observe it at the same time every night,
Mars,
where it would be. I mean, obviously from Mars, but also you're not talking about it sort of one of them seems to be zooming across the sky in one direction and one zooming across. You're talking about same time every night.
Yeah.
If you were to see where they are in the sky, then
Yeah.
one of them would be a little bit further, more towards the west, and one of them would be a bit further towards the east, but they're
Yeah.
moving in opposite directions.
Which would be so weird.
Oh, it just does my head in. I mean, this is the worst part about orbital dynamics, orbital mechanics, is not only is it hard enough to put all of these multi-body problems together, just dealing with one body is hard enough. Two bodies we can do. Three bodies is next to impossible. But then you've got to put yourself in the position of, but we're standing on Earth. And so even though we're not the center of the solar system, we see it that way. And so what do things look like in the sky? And then you've got to add on, and we're standing on Earth and it's rotating. And then you've got to add on, and we're standing on Earth and it's a sphere. So we're not on the equator. We're actually quite a long way up and pointing up at it. It's really hard.
It's really hard. And then you've got all the perturbations that happen to these orbits, all the tiny things that can change them. So I'll tell you a story. I did a course in celestial mechanics when I was an undergraduate at university. And we spent, a lot of lectures learning about perturbations to the moon's orbit. So you get different tidal forces, different tugs and pulls on the moon.
So when you say perturbations, you mean like we could describe the moon's motion in this very broad terms. It's basically going around the Earth in a circle. But if you add in, it's slightly different because we have to put in this little correction. And that's what you mean by a perturbation. It's a bit different from that easy one that we can talk about. It's slightly more complicated. And then it's slightly more complicated again. And then we perturb it with this particular bit of mathematics and so on.
Yeah, exactly. And then so we spent a lot of time learning a lot of maths to deal with all these perturbations. We got up to something like 10 or 12 different perturbations to the moon's
and that's
orbit.
Just the moon.
In many, many lectures. And then sort of in the second to last lecture, the professor says, so there are actually more than 40 different perturbations to the moon's orbit. And at this point, we all just sank our heads into the tables and thought, we need a computer program to solve this now.
And even then, the computer program, someone still had to work out all 40 of those, right? And build in, and that's just the moon. That's just,
and now think, we went to the moon before we had a computer program to do that.
That's nuts. That's bonkers. Right, well, we've given you a challenge, listeners. In the show notes, you will find the checklist, and we want you to go and fill that one in. Get as many of those as you possibly can. Some of them are really easy, like Venus. Go and, that's the easy one. You can pretty much probably tick that one off already. But get the others as well. There's nothing on there that you can't see, with the possible exception of Which one was it that they have to go to the southern hemisphere if they're in the north? That was the
That's Alpha Centauri.
right. Okay, so asking you to fly around the world, maybe that's a bit too.
Get one of the exoplanets. I think that's fair. Right?
Yeah, like just get one of the that's fair enough. But do it. I think that'd be awesome. And if you can get Neptune before Emily does, you get bonus points, I would say. But look, we've been rabbiting on about planets in our local neighbourhood for a very long time. It's time to wrap this one up. Emily, if people want to get in touch with us, like our new patron Keith, how would they do that?
So we are on Twitter.
Yes, we are.
At Syzygy Pod, SYZYGY Pod. In fact, Syzygy Pod all over the universe.
Yep. Yes, and particularly the universe of social media. You can find us at syzygy.fm. You can find all of our past episodes in the show notes and a contact form where you can say hi and send us questions, queries, ideas, thoughts, compliments. Always nice. And speaking of compliments, why don't you just stop right now and go and leave us a little review on your podcast app of choice. A couple of stars and a few sentences to tell the world how much you enjoy listening to the show. Because I know you do, and that'll help us to rise up through the noise and find more people who can share in the joy of planet spotting.
Yep. There's one more place you can find us this month.
Oh, go on, yeah.
It's Thirsk.
Of course, the centre of the podcasting universe. Thirsk, we are going to be there on the evening of Friday the 22nd as part of the Podcast Social Club Festival. That's happening on Friday the 22nd and Saturday the 23rd. Podcasts across the galaxy of different podcast topics. There's stuff about cooking and stuff about veterinary, and there's people telling jokes, and there's us talking about astronomy. If you're into podcasts, you will find something enjoyable. So if you're in the Thirsk area or want to travel, check out podcastsocialclub.com and come along and join us in the audience. It's going to be fab. Otherwise, we're going to have to wrap that one up. We'll catch you in about a week's time. See you later, Emily.
See you later.
Bye, everybody. If you see a red dot in the sky, it's a good sign it's Mars. I'm asking you a question.
No. I totally spaced out.
Yeah, you did there. Should we try that one again?
Hang on, let me just have some more.
Have some more coffee. Do you need some more cake? We've lost Emily at the 45-minute mark.